Welcome back to Spring Into Math. I'm Mr. Burns, and I'm going to be your teacher today. Today's topic for our lesson, cube roots and square roots. So let's go ahead and get started on figure out what both of these actually mean. Square roots, guys. Let's think about what that actually means. Let's break it down a little. Squaring a number means multiplying a number by itself. So to square 3, and another way to say that is to raise it to the second power, we multiply 3 times 3, which looks like this. It's highlighted in yellow for you. We have that big number 3, which is your base, and that small number on top is your exponent, which is the 2. And there are 2 square roots for every positive number. Let's take a look at what that means. For example, the square roots of 36 are 6 and negative 6, because 6 squared, or 6 times 2, is equal to 36. And negative 6 squared is actually negative 6 times negative 6, which equals 36, because those two negative signs cancel each other out when you multiply them together. So a perfect square, such as 121, has an answer that is both positive 11 and negative 11. If a square root is not a perfect square, it will have a repeating decimal or a terminating decimal, which we talked about those two topics back in Chapter 1. Cube roots. Cubing a number simply means you'll multiply itself 2 more times. So to cube 3, we're actually going to multiply 3 times another 3. Cubing stands to multiply things by 3. Okay, so here we have it broken down for you. 3 times 3 times 3. What it looks like is actually 3 raised to that third power. That base, the big number, is 3, and this time the exponent is also a 3, which is the smaller number raised above the larger 3. And the symbol for cube roots, guys, is down at the bottom of our page, and it's highlighted in yellow for you. It looks like the square root sign, except we add in a little 3 there, so we know that it's a cube root. There is 1 cube root for every positive number. And my example here at the bottom is a cube root of 8, which looks like the little division bar with a line sticking out the side, which has the 3 on it. So the cube root of 8 is actually 2. And that's because 2 times 2 times 2 is 8. Remember, when we're working with cube roots, we have to think about things in pairs of 3. To undo a cube root, we take the cube root of a number. So we have the problem, the cube root of 64. We need to think about what number, when it's multiplied by itself 2 more times, is going to give us that number inside the cube root box, which in this case is 64. So I think about what 4 times 4 is, and that's 16. And I have to multiply it by 4 one more time to see if I can get up to 64. And guess what? 16 times 4 does equal 64. So the cube root of 64 is 4. And again, remember, when we're looking for our answer, we need to make sure we're multiplying things by 3 different times. A number that is a perfect cube has an integer answer. The number 27, for example, is a perfect cube, because if I take the cube root, or I undo the cube root from 27, I get 3. And 3 times 3 is 9, and 9 times 3 is back to 27. A cube root that is not perfect will have a repeating or a terminating decimal. All right, let's solve a few of these together. So I have here x squared is equal to 81. So what I need to think about, the process I personally go through, is what number can I multiply by itself to get back to 81? Well, we've learned our times tables long ago, so we should know that. Get my pen on here, guys. There we go. I have 9 times 9. And 9 times 9 gives us that answer of 81. So 9 squared is equal to 81. All right, let's look at a cube root one, or something that we're going to cube to get to a large number. The example says x cubed is equal to 729. Well, I need to figure out what number multiplied by itself 2 times is going to get me back to 729. Now I know that 10 times 10 is 100, and 100 times 10 is 1,000. So 10 is too big. So let's go and try for 9. So 9 times 9 is equal to 81. And now if I multiply it, now I only multiplied it twice, and I need to multiply it by 9 a third time because we're working with cube roots. So I'm going to multiply that by 9 again. And 1 times 9 is 9, and 9 times 8 is 72. So we did find the answer. 9 cubed, or 9 raised to the third power, is equal to 729. I'm going to go ahead and erase that so we can work on our next problem. All right. This one's a little more tricky. We have x squared is equal to the square root, and inside our square root symbol, guys, it's actually a fraction. This could be a little confusing. So x squared is equal to the square root of 16 over 169. Now, I need to think about, let's break this down a little. I know that I'm going to need to work with a fraction. So I'm going to draw my fraction bar here. And I'm going to tackle the very first part, 16, which is our numerator. And we can figure out pretty easily what number multiplied by itself is equal to 16. In this case, it's 4 times 4. There we go. So on the top of my denominator here, I can write 4. OK. So now I need to figure out what number, when I multiply it by itself, is going to equal to 169. Now that's a big number. I know that 10 times 10 is 100, so it's got to be quite a bit bigger than 100. 20 times 20 is 400, so it needs to fall somewhere between 10 and 20. I'm going to go ahead and try the number 13. So 13 times 13. And if you work out 13 times 13, guys, we're actually going to get 169, which is the exact number that we're looking for here. So my conclusion and my answer here is that x squared, which is, we need to figure out what fraction when it's squared, is equal to 16 over 169. And in this case, the answer is 4 over 13. And if I were to put this in parentheses and square it, we would use the one of the rules we learned earlier. We would actually square both those, and it would get us to our original fraction. All right, guys, that's it for today. Hope you had some fun. Good luck solving.